Hi everyone, so today we are going to solve a very important problem, that is we have to find the path exists in graph or not. It is a very important LeetCode problem which is under easy category. We'll look at it and then solve it. Firstly, this problem says that we need to check if the path exists or not. Yeah, so we are given a graph and we are supposed to do is that we need to find that from the particular source vertex if there is a path existing to the destination or not. हमें वर्टिसेस दिए हुए हैं, हमें फाइंड करना है कि सोर्स से डेस्टिनेशन का कोई पर्टिकुलर पाथ है या नहीं. Okay, so for example, this is an example, that is 0 is in vertex, 1 is in vertex, 2 is a vertex. This is a graph. Edges are given to us 0 to 1, 1 to 2 and 2 to 0. Because it is a bidirectional graph, then it means that 1 to 0 edge is there, 2 to 1 edge is also there, 0 to 2 edge is there. It is a bidirectional graph. Bidirectional graph is given to us. We just need to find out that if there is a path which is existing from source to destination vertex or not. This is what we will be doing here. So we'll start doing this problem using depth first search. How we'll be doing it is that we will be traversing this complete graph from the source vertex and will try to reach to the destination vertex. We will do it using DFS, means we'll go to the depth from 0 to 1, then to 2 and so on. Let's say we'll find the destination, we'll stop there. Okay, so we'll start it. Firstly, what we'll be going to do here is we'll convert this edge list to adjacency list, which will make it easier for us to solve this problem. Firstly, we'll create our answer or we can say our adjacency list. Okay, so this list of type integer, this is our adjacency list. Okay, new array list. It is given to us in the problem that there are n vertices. N is 3 in this example. So n is the number of vertices. Firstly, what we'll do is जो हमें complete हम adjacency list बना रहे हैं, अब हमारे पास लेट से 3 vertices हैं, तो हम ये कंसिडर कर लेंगे कि जो हमारी मेन लिस्ट है इसका साइज इज 3. ओके, अब इन 3 साइज यानी ये जो 3 हमारे पास वर्टेक्स हैं, इन तीनों से एसोसिएट एक लिस्ट होगी. ओके, इस तरह से वर्क करेगा कि पर्टिकुलर जितनी भी वर्टिसेस हैं उन सब से एसोसिएट एक लिस्ट है एंड उस लिस्ट के अंदर हमने स्टोर किया हुआ है कि इस पर्टिकुलर वर्टेक्स से इन सभी वर्टिसेस ने एक एजेस बनाई हुई है. ठीक है, ओके, तो स्टार्ट adding this list to every of the vertex 0 2 and what we'll be doing here is we'll create a list of type integer, let's say L, we can say it list, array list, and we'll add this to adjacency list, which is empty before this, which do not have any data, just the size is given. Now we'll add list to every of the vertex. So we'll add this list. We have added it to every vertex, means to every element of this list. Done. Now what we'll do, we will change our edge list to adjacency list. We'll traverse the complete edges array, 2-dimensional array. We can do it using edges.length. And now what we can do is we have to add our element to the adjacency list. How we can add? We can get the element and then place it. Let's say we have an edge 0 to 1. So firstly we'll find out 0 from the adjacency list. So how we can find out? Edges of, what is this? This is j and index is 0. We'll find this out and then what we can do is we can add edges of j1. As we know that this graph is bidirectional, so that's why we can take it bidirectional in case of adjacency list also. Take 1 and add 0. This is how we can form the adjacency list using the edge list. Now using this adjacency list, we will do DFS and we'll check if the path is existing or not. But before going to that, we'll first create an array, that is array to check if the element has been visited before or not. Okay, so we'll do it this way. Size of this is also n. Initially we can consider that all the elements are not being visited before, all are visited of them are false. So if it is false, then we can move ahead, we can take it to n itself. Okay, then visited of this k is equals to false initially. Then we can call our DFS method. What will be passing in DFS is firstly our adjacency list will pass, then we'll pass the source, and then we have to pass the destination and also the visited array. Visited array will keep track of if the element has been visited before or not. Okay, now we'll create a new method, that is return type is boolean, DFS, list will remain the same. Okay, and source and destination, these are the ones. Okay, and next one we have is a visited array. This is the parameters of this method. Now firstly we'll check that if the source is equals to destination. Let's say we can have the case when we have just one vertex and we have reached to the claim that there is a path from source to destination. We'll check it in the beginning, and if it is true, we'll return it true. Next, your aim is we'll mark the particular vertex as true. Visitor of source equals to true. Done. Now we'll traverse the complete list associated with every vertex to check it out that if path exists or not. We'll continue traversing this. L equals to 0 to L will go to the list of that vertex. How we can get to that? Adjacency list, then get the particular source out of it. After getting the source, you can check the length of it. Done. Okay, then what we can do is firstly we'll check if this has been visited before or not. So we'll check if visited of adjacency list dot get source dot get the particular value. If this is false, then only we can go ahead. How we'll do? We'll just recall the DFS, and what we can pass is firstly we'll pass the adjacency list, then we'll pass the particular element, the next element we are going to call on. So this is our next element, this is our source now, so this will be passing. Okay, and next is our destination, which will remain the same till the end, and next is our visited array. So we'll pass our visited array. Firstly we have marked that if it is true, firstly we'll mark that if we have visited it, we'll mark it true. Then moving ahead, we'll traverse the complete list associated with it, and after traversing, if we find out that this is true, then we'll return true. If this b is equals to true, then we'll return true, or else we'll return false. We are supposed to use the size method here, size method of the list. Okay, so we are done. We'll discuss this once more, just summarize how we have done it. We are trying to find out the path. Then firstly what we have done, we have converted the edge list to adjacency list, then we have started our traversal. Firstly we have checked कि हमारा सोर्स और डेस्टिनेशन सेम है, अगर सेम है तो हमने ट्रू रिटर्न कर दिया, अगर नहीं तो हमने फिर चेक किया कि हमारी एडजेसेंसी लिस्ट में जो हमारा सोर्स है उसका साइज़ कितना है। साइज़ चेक करने के बाद हमने चेक किया कि विजिटेड अगर वो एलिमेंट नहीं है तो ही हम आगे बढ़ेंगे, विजिटेड है तो हम उसको बार बार विजिट नहीं करेंगे, बिकॉज अगर मुझे बार बार विजिट करने लगेंगे तो साइकिल फॉर्म हो जाएगी। फिर अगर वो विजिटेड नहीं है तो हम आगे गए और हमने कहाँ पर कॉल किया, उस पर्टिकुलर एलिमेंट पे कॉल कर दिया। हम यहाँ से देख सकते हैं एग्जांपल में 0 1 2 जहाँ पर है, फर्स्टली हम 0 को मार्क कर देंगे ट्रू, हम आगे जाएंगे, हम उसकी लिस्ट में देखेंगे 1 उसका एक नेक्स्ट एलिमेंट है, तो हम 1 को चेक करेंगे, 1 पहले विजिट हुआ है, वो बोलेगा 1 विजिट नहीं हुआ है, देन वी विल से कि ठीक है 1 पे फिर से डीएफएस कॉल करो, 1 पे डीएफएस कॉल करेंगे, नेक्स्ट टाइम हम 1 को विजिटेड मार्क कर देंगे। ओके 1 को विजिट मार्क करने के बाद 1 का नेक्स्ट एलिमेंट हमें लिस्ट में क्या मिलेगा 2। ओके 2 को चेक करेंगे, 2 विजिट हुआ है, नहीं हुआ है, नहीं हुआ है तो हम फर्दर आगे बढ़ेंगे। आगे बढ़ते वक्त हम चेक करेंगे कि क्या 2 हमारे डेस्टिनेशन के इक्वल है, क्योंकि 2 हमारे डेस्टिनेशन के इक्वल हो जाता है और हम इसी टाइम पर ट्रू रिटर्न कर देंगे। तो दिस इज हाउ वी हैव सॉल्व्ड आवर प्रॉब्लम। For any query or any doubts, please ping in the comment section. I hope you understood the problem. Thank you.